A small local high school is looking at hosting the dinner and dance for their prom at the Rosebud Hotel, where they charge a $500 setup fee and $75 per person. The Rosebud's competition, the Firefly Inn, claims that it'll cost the same amount, even though they charge a setup fee of $1,000, but it's only $50 per person. How many people need to attend prom for Firefly's claim to be true? Let's start by looking at these offers algebraically. Rosebud is saying that their cost is $500 initial setup fee plus $75 per person, which we will use the variable P. At Firefly, they're saying that the cost is equal to the $1,000 setup fee plus $50 per person, or P. Now, this is the initial value, or what the prom committee will have to pay regardless of how many people show up. It's constant and doesn't change. You'll notice that Firefly's initial cost is much higher than Rosebud Hotel's. But their variable cost depends on the number of people who show up, and Firefly's is much lower. We want to know how many people need to attend for the price of both places to be equal or equivalent. So we've got to figure out how many people need to attend both Rosebud and Firefly for their prices to be the exact. Let's subtract the Rosebud setup fee since we're going to see the difference or how much more Firefly is. So that gives us $75 per person is equal to just a $500 setup fee plus $50 per person at Firefly. Now let's look at the difference in terms of price per person. So it's a $25 price per person difference. So we've considered that $25 per person difference is equal to the $500 setup fee. $25 per person divided by the $500 setup fee will account for when the price will be the same. The cost of Firefly and the cost of Rosebud will be the same if 20 people attend prom. We can also look at a graphical representation of this question. I used the online graphing tool Desmos to graph the two equations that we've been working with. You'll notice that I changed the variable of p to x to graph it. Here are the two linear equations graphed out. Let's label our x and y axis for this situation. X is the number of people, and y is the cost of the event. This is the linear equation for Rosebud. We know this, aside from looking at the color coding, because when the number of people is 0, you will still have to pay the initial setup fee of $500. You'll also notice that this graph extends past 0. Because it is a linear equation, it will continue to extend in both directions. But for the context of this problem, we're only interested in 0 or more people attending prom. This is the point of intersection. It's when the two lines cross. This is when their cost will be the same. Using this graph, we will see that it will happen when 20 people attend, and that total cost will be $2,000. Now, this graph gives us more information than when we did just the equivalency of equations. Firefly is claiming that the cost would be the same, but looking here, if less than 20 people go to prom, remember this is a small school, it is more expensive to host at Firefly. But if more than 20 people attend, Firefly will actually be a less expensive event.